Okay, in 2.7, we're going to look at combining functions. So with combining functions, algebra of functions, we're looking at a couple things. For example, f plus g of x means the same thing as f of x plus g of x. We're taking two functions and we're going to be adding them. All right, so that was just the first example of what it means to combine functions. All right, so basically take a function, f of x and g of x, and add them together. Combine like term, etc., whatever you have to do. Same thing for minus. F minus g of x is f of x minus g of x. And then subtracting two functions, distributing that negative to the second function. F g of x is the same thing as multiplying the two functions. F of x times g of x. You might have to FOIL, distribute, combine like terms. And then f divided by g of x is equal to f of x divided by g of x, where obviously the denominator cannot equal 0. The domain, you got to be careful with the domain. The domain for combined functions is the domain of both. So what that means is if something does not work in one of the functions, it is still part of the domain, or not part of the domain, I should say. Like if one fraction has an x on the bottom and the other one is x minus 5, well, you still have to cut out 0 and you have to cut out 5 because you can't divide 0 into one of the original functions, no matter what you're doing with the two functions. Okay, let's use graphical addition. If we look at graphing using addition, so f plus g of x, it's obtained by adding the y values of the two functions. So let's take a look at this. I have two functions on this graph where I have g of x, this blue line, and I have f of x, this purplish line. And if I look at the y values, I'm basically adding. So if you look at right here, this point right there, it looks to be about 1, all right, for the purple graph. If I go up to the blue one, it looks to be about 5. Looks to be about 5. And if I add those up, 1 plus 5 would give me 6. It gives me the point for this purple one, which is f plus g of x. So adding f of x, this value of y, and g of x, this value of y, gives me 6, gives me f plus g of x, the value of f plus g of x. I can do that anywhere. I can add up any y values along both graphs, and I would end up with this purple graph. Okay, the graph of f plus g of x. So I have two functions, f of x and g of x. So let's do it. If I wanted to add f of x and g of x, f of x being the red line and g of x being the blue line, I would add the y value. So let's just do that. I'm going to use green to be f plus g of x. So I'm looking at the y value. So here, the y value is 0, and here, the y value is negative 2. If I add 0 plus negative 2, I still have negative 2. Let's do it here. This value of y is 1, right there. Oops, didn't line up perfect. It's 1. And this value of y is negative 2. When I add those up, 1 plus negative 2 is negative 1. All right, I'm actually going to use black so you can see the points that I really want to use. Green ones are just to get me to add them up. All right, negative 1 plus 2 is positive 1. So negative 1 plus 2 is a positive 1. Right there. I'll add them up. Negative 1 again and 2 again gives me 1. Going here, this is negative 1 and 0 gives me negative 1. Point there. Negative 2 and 1 gives me a negative 1. So negative 2 add up with 1 gives me negative 1. Keep on going here. Negative 1 right here, g of x, plus 2 from f of x. Add those up, gives me 1. Black here. And finally, negative 1 plus 1 gives me 0. Now, all I gotta do is connect them for f plus g of x. Okay, so it looks like it goes from here there, there, and then down, there. Get that one right. Yep. And then there, all the way to there. Right? Not the most perfect graph, but that is exactly what we're doing. We just added the two functions. All right. Added the two functions. Good. Moving on. Okay, let's review a couple of things. We have f of x equals x squared, g of x equals x minus 1, h of x equals the square root of x. If I had f of 2, that means I'd plug in 2 for x. I plug in 2 for x and solve that. All right, obviously that'll give me 4. If g of x is x minus 1, I put negative 5 in for x. Negative 5 minus 1 would equal negative 6. And then h of x equals square root of x. I put 16 in for x, it'd be the square root of 16, which equals 4. No problem. Remember that. Composition of functions. Composition of functions means plugging one function into another. So the notation is said like this. F of g of x, so f of g of x. Or it can be written like this. I used to call it fog, f of g of x. Or you can just write it fog all by itself, f of g of x. And generally what it means is take g of x first and plug it into f of x. You could also have g of f of x, like this one, g of f of x. And I would take f of x and plug it into g of x. So let's do both of these. First it wants me to do f of g of x. So I'm going to take g of x, which is the blue one. I'm going to plug it into f of x for x. All right, here we go. So f of g of x means I'm going to take the function f of g of x, I'm going to plug g of x into f of x. So let's see what we have. F of x is x squared. Let's say x squared. Something has to go in the place of x. It's x squared. Well, what goes in the place of x? G of x does. What's g of x? G of x is x minus 1. I'll plug that in right there. All right? So in the place of x, or f of x, right here in the place of x, right there, I took this entire thing and put it in that spot. I use a parenthesis. Now I can go ahead and clean it up. All right? We all know that x minus 1 quantity squared is like x minus 1 times x minus 1. And if I FOIL that, f of g of x equals x squared minus 1x is minus 2x plus 1. G of f of x. I'm going to do it the other way. G of f of x. Now, I want to plug in the place of x. So x minus 1. So it will look like this. In the place of x minus 1, I'm going to plug in f of x. What's f of x? F of x is x squared. So in the place of x, I'm going to put x squared. And that's simple. That's just x squared minus 1. That is composition of two functions. Okay, so now what I want to do is I want to find these functions. Example 5, I want to find f of f, f of g of h, and f of g of 4. All right, so if I do that, f of f just means plug f back into itself. So this would just mean f of x means take f of x, plug it back into itself. So I have x squared. In the place of x, I'm going to plug x squared, which is just x to the 4th. F of g of h, I'm actually doing it 2 times. I'm doing the h of x into g of x. So first I'm going to take h of x, I'm going to plug it into g of x. All right, so first I'm going to do that. So g of h of x equals, in the place of x, all right, I'm taking square root of x and I'm plugging it in there. Square root of x minus 1. Now I'm going to do f of g of h of x. I'm going to take this whole thing, I'm going to plug it in for x right there, for x. So that will equal f of g of h would equal, in the place of x, I'm putting square root of x minus 1 squared. And now you can FOIL that out. I'm going to do it over here. I can FOIL that out. That would be square root of x minus 1, square root of x minus 1 equals x minus 2 square root of x plus 1. There you go. Circle these so you can see them. And last, f of g of 4. All right, that's like taking the value of 4, plugging it into g first, and then plugging it into f. All right, you could find f of g of x first, which I think we did on the previous page. F of g of x will be x squared minus 1. So we found that in the previous slide. It ended up being x squared minus 1, which means that you just have 4 squared minus 1, which is 16 minus 1, which is 15. Okay, in the next video, we'll talk a little bit more about composition, looking at graphs. Actually, no, I'm going to clean it up. I'm going to finish it up right now by looking at the graph and doing composition. No problem. All right, so g of f of negative 4. I can find f of negative 4 by looking at f and looking at the x value. I see that this value is 2. So f of negative 4 is actually negative 2. And I take that, plug it into g. So I go to g, I find negative 2, find the value is 2 right there. So I took negative 2, found it in g, went up to it, and it ends up being 2. Let's do g of 4. So g of x at 4, g of x at 4 is equal to 1. That's the first one. G of 4 actually equals 1. And so now I'll find 1 in g of x. Here's 1, follow it down, equals negative 2, right there. So I used 1 after I found g of 4. I used 1 after I used g of 4, which I found it right here. There's 1. And then I used g of 1, plugged it back into itself. So I go to 1, I trace it down, trace it over, gives me, negative 2. I almost had that. Okay, let us know if you have any questions. You can ask questions in class. Otherwise, make sure you rewind the videos, go back and look at the videos, and get it all figured out.